This is a short lecture where you're going to learn about CIDR, which is classless inter-domain routing. A problem with the original implementation of the classful addresses was that when the internet authorities gave out addresses, they always gave out a complete class A with a /8 or a complete class B with a /16 or a complete class C with a /24 subnet mask. And this gave the problem that if a company had more than 254 hosts, they were too big for a class C, they would have to be given a class B. And if they had, say, 500 hosts, they would actually get allocated addresses for 65,534 hosts. So that's obviously way too much. And this led to huge amounts of the global address space being wasted. So CIDR, classless inter-domain routing, was introduced in 1993 as the solution or a partial solution for that problem. So CIDR removed the fixed /8, /16, and /24 requirements for the different address classes and allowed them to be split into smaller networks. And the name for this is subnetting. Again, we're going to be talking about subnetting a lot in the later lectures as well. So, for example, the Internet authorities could allocate the address 175.10.10.0/20. You can see from the first octet, 175, that that is a Class B address, which would normally be a 16, but rather than allocating the organization the entire class 16, the Internet authorities could now assign them a /20, which meant that other networks in that 175 range would be available to give to other companies. So rather than giving out the huge range, we split the classes into smaller networks that could be given to different organizations and meant that there would be less addresses getting wasted. So companies can now be allocated an address range that matches what they actually need and doesn't waste extra addresses. We get another benefit from CIDR as well, which is route summarization. You see in the example here, we've got ISP-A. And they have allocated the address blocks that you see on the left. So one company got 175.10.0.0/24, another one got 175.10.1/24, 175.10.2/24, etc., all the way up to 175.10.255.0/24. So they've given out 255 address blocks there. We've also got ISP-B, and they've given out 175.11.0, 175.11.1, and so on, again /24s, all the way up to 175.11.255. And ISP-A and ISP-B get connected. Now, if we didn't have CIDR and we weren't able to do route summarization, ISP-A would advertise, it's actually 256 address blocks there, they would advertise all 256 address blocks to ISP-B, and ISP-B would vice versa advertise all their 256 address blocks to ISP-A. But when we've got CIDR and route summarization, what we can do is the two ISPs can advertise just an aggregate block. So ISP-A, rather than advertising all 256 /24s, it advertises 175.10.0.0/16, which is a superset of all those 256 smaller networks. So now ISP-B, it only learns one route to all the networks behind ISP-A rather than learning 256. And ISP-B will vice versa just advertise one route of 175.11/16 to ISP-A. So the benefits we get from this is that ISP-A doesn't know about all 256 networks behind B. It only gets a single summary route that covers all of them. Obviously, if it's got one route rather than 256 routes, that's a lot less information. It's more efficient. It takes up less memory in the router. And if an individual link goes down in ISP-B, it doesn't have any impact on ISP-A because that one summary route doesn't change. It's going to be different in ISP-B. Whenever one of their routes goes down, the other routers are going to have to recalculate that. But the benefit we get from this is we're compartmentalizing the different parts of our network. And if we've got an issue in part A of the network, it's not going to impact part B of the network. So it makes things a lot more stable and reliable, makes things more logical, which is better for us humans as well, because it makes it easier to troubleshoot them. Okay, that was CIDR, which is closely related to VLSM, our variable length subnet masks. We'll be getting to that real soon too. See you in the next lecture.